Okay, there's two ways we can tackle this problem. First, what we can do is recall that this number being multiplied by the log can go back into this spot as the exponent on the number. So this problem would become log of x plus 2 to the power of 1/2 equals 2. Notice that there is no base shown here. That means it's a common log and the base is 10. And so when we have something in the form of log of base b of n equals e, and that's read log base b of n equals e, that we can rewrite this in exponential form or Ben form. So we take that base, raise it to the power of the exponent, and set it equal to the number. So if I do that for this problem, I'd have 10 squared is equal to x plus 2 to the power of 1/2. Well, 10 squared is 100, and when you raise something to the power of 1/2, that really means you're taking the square root of it. And so to get rid of that square root, I would square both sides. Now when you square 100, which has 2 zeros, the result will be 4 zeros, or 10,000, equals x plus 2. And when you subtract 2, you'd have 9,998. Another way you could go about this problem is to say, okay, I'm going to multiply both sides by 2 to get rid of the half. So if I multiply both sides by 2, I would have log of x plus 2 equals 4, and this base is still 10, and if I write it in exponential form, I would have 10 to the 4th equals x plus 2, and 10 to the 4th is 1 followed by 4 zeros, which is 10,000. So 10,000 equals x plus 2. Subtract the 2 to get 9,998 is equal to x. Either way, you get the same answer. When solving a trigonometric equation, we like to replace the trig function with an x and solve that for x and resubstitute the trig function back in for the x after we've solved it. So this results in 2x minus 3 equals 3x minus 4. If I subtract 2x from both sides and then add 4 to both sides, I would have x equals 1, which means tangent theta is equal to 1. Now from our knowledge of our special values, tangent of theta would be equal to 1 if our reference angle is 45 degrees. Now, the answer in this problem is positive 1, and we know from our ASTC chart that we need to go into the quadrants where tangent is positive. That would be where they're all positive and where t for tangent is positive. So in quadrant 1, our answer would be, that's supposed to be a theta. Theta is 45 degrees, and in quadrant 3 it would be 180 plus 45, which is 225 degrees. When writing the equation of a circle, we need to write it in x minus h squared plus y minus k squared equals r squared form, where h and k are the coordinates of the center of the circle. In this example, the center is at -5, +3, and so I'm going to have x minus the -5 squared because h is -5. This minus comes from the formula, and this minus comes from the fact that the x coordinate of the center is -5. I'll also have y minus 3 because the k value is 3 squared, and this is equal to the radius squared. I can change x minus -5 to x plus 5 squared plus y minus 3 squared. And now I need to find that radius and square it and put it in here. So how do we find the radius? Well, the radius is the distance from the center to a point on the circle. The 2 points that we have are and -1, 7. And the formula we're using for the distance is the change in x squared plus the change in y squared, and then we take the square root of that. So the change in x would be -1 minus -5, or 4. And when I square that, I'd get 16, but I'll put 4 squared in for now. And the change in y would be 3 minus 7, which is negative 4. I need to square that when I put it into the formula. So 4 squared is 16. Negative 4 squared is negative 4 times negative 4, which is 16. So this becomes the square root of 32. That's the radius, but to put it in the formula, I need to square it. So when I square square root of 32, it just becomes 32. In example 8, I can use the law of cosines to find the side across from the angle. Anytime we have two sides in the included angle, that's a law of cosines problem, and I can find the side across from the angle. So I'm going to go ahead and fill in the formula, which is a squared equals b squared plus c squared minus 2bc cosine of a. And when I fill that in, so I filled in the formula, and what I do is I just type this entire expression into the calculator, hit enter, and then I took the square root of it. I didn't round the answer, I just wrote the entire value down. So that means that this side is 10.7314, and the question is asking us to find the measure of the smallest angle. Well, I found a side, but I had to find a side so that I could then use the law of sines to find the measures of the other angles and decide what the smallest angle is. Now that I know this side and the angle across from it, I can find either of the other angles. I'm going to go ahead and find the angle across from side 6 using the law of sines. So I went ahead and filled in the law of sines. Now if I cross multiply, I'll have 6 sine of 80 is equal to 10.7314 times the sine of x. But I'm also going to just divide by the 10.7314 to get sine of x. And now I know that I'm trying to find x, which is an angle, and I don't know the angle, so I'm going to inverse sine this value, and I'll end up with x is equal to 33.4091 degrees. That means our three angles are 80, 33.4091, and if we add those up and subtract from 180, the result would be 66.8909 degrees. That means the smallest angle is 33.4091 degrees.